mainstream astronomers' reliance on gravity as the primal force shaping the universe has restricted them to thinking in terms of spherical explosions and voids or bubbles created by dying stars. Around these supposed voids, gas filaments can be seen arcing away. Our Sun sits in the middle of an enormous void called the local bubble. They say this contains million-degree ionized hydrogen gas, surrounded by a wall of colder, denser neutral gas. Within this hot bubble, gas density is much sparser. At first they thought that the local bubble was an asymmetric cavity of 330 to 490 light years in diameter. This implied that two bubbles might have collided and merged. The most important point to note is that they believe the local bubble is deficient in neutral gas. In all the literature they keep describing it as neutral gas deficient, rather than simply stating that it is highly ionized. Further mappings revealed that the ionized pockets actually form a tunnel that extends at least 820 light years towards Ursa Major, suggesting that it might connect at least 1,000 light years into the galactic halo. As the research continued, it started to become clear that our local bubble was actually part of a larger cylindrical cavity that pierces through the disk of the galaxy, dubbed the local chimney. So how do they explain the formation of the bubbles, and how can they explain the structure of the local chimney? They believe supernova explosions are responsible for creating these voids. In the case of the local chimney, they speculate that energetic supernova explosions created fast-moving expanding bubbles of hot gas that collided with surrounding cold gas of the interstellar space, which in turn became compressed into thin shells. Eventually these shells of cold gas meet other expanding hot cavities and break up, forming small tunnels or pathways between the expanding voids. Towards the centre of the local chimney we find the Pleiades, and it is here that astronomers search for the possible source of the supernovae. A little further out from these are a belt of stars called the Gould Belt. These are massive hot OB-type stars. These provide a clue as to what might be going on. The supposed young stars appear to form a ring centred on the Pleiades, and have motions that appear to imply that they are also orbiting around this point, yet there is not enough mass for this to be possible. Let's just take a little step back here. Are we surprised that our Sun sits in a bubble of ionized hydrogen? No, this is exactly what we would expect to find. Our Sun sits on a filament which powers our star. The fact that this structure seems to take on a cylindrical appearance should also not come as a surprise. So what are we to make of the boundary layer of cooler gas surrounding this structure? Assuming that the filament takes on a simple Birkeland current structure, we would expect recombination to occur. Markland identified this process and showed that the elements will become preferentially sorted according to their ionization energy. This means that hydrogen and helium would always be found towards the outer edges of a filament. So comparing the density of hydrogen inside the filament to the outer edges, you should see a sharp increase in the density and the appearance of a wall. If we examine this image, then we see that the areas in white are low density, probably hot ionized gas, so in other words, plasma. The darker coloured areas are thought to be cold, dense gas, possibly largely molecular in nature. We can clearly see that many areas seem to connect to each other, forming a sort of network. Now it is important to point out that there is likely to be many smaller filaments connecting and overlapping, creating this blurred white part of the image. From Jim Weniger's work on Arcturus, we can see that the motion of the stars may reveal parts of this structure nearby us, with us circling around the local Arcturus filament. Some astronomers have wondered if the local bubble or chimney system of interlocking gaseous cavities is characteristic of the entire Milky Way. Astronomers looking at an updated map of cold local interstellar gas in the galactic plane see an inner empty region with finger-like extensions or tunnels that poke through the surrounding wall and reach into the nearby regions of the galaxy. These regions are known to contain large amounts of hot, ionized, low-density gas that can be detected at radio and ultraviolet wavelengths. Right next to our local bubble, astronomers have identified a new bubble called the Pertau shell. It is thought to extend for about 500 light-years and spans two well-studied molecular clouds called Taurus and Perseus. Using a special technique, they were able to create three-dimensional maps of the local cloud structures. If we examine the chameleon molecular cloud, we can see a series of filaments that seem to connect via a hub-like structure, with a void in the center. It is also physically connected to the Musca dark cloud. The Taurus cloud extends between 131 and 168 parsecs. When viewed from the top, you might be able to notice that it consists of two layers separated by about 10 to 15 parsecs. This layering is consistent with several previous studies. Musca is a clear example of a filament on both a two-dimensional and three-dimensional image. It is termed a dark cloud, meaning that it contains a myriad of sub-micron-sized solid particles, often referred to as intergalactic dust grains. They tend to block out visible light, making them appear dark. They are thought to be composed of largely molecular gas rather than containing ionized material. Ultraviolet starlight is considered the main source of ionization in H2 regions, and in H1 regions it ionizes elements with low ionization potentials. This has led to the belief that it is the only ionizer, and that in dark clouds where starlight is absorbed, the ionization may go down to zero. This is not necessarily correct, because in many cases most ionization of cosmic plasma is produced by a hydromagnetic transfer of kinetic energy into electrical currents which ionize. One common theme that they identified was a point I touched on earlier: the creation of the atomic hydrogen envelopes around the molecular clouds. They also discovered that the widths between the outer and inner envelopes had a consistent ratio of 3.4. When they identified the radial density profiles, they found that it was inconsistent with a filament driven only by gravity, and was much better suited to one where the filaments were magnetized. Previous studies of the structures of magnetic fields in the solar neighborhood clouds have found strong coupling between the gas column density and the magnetic field orientation, which is consistent with the idea that magnetic fields play an important role in structuring the interstellar medium in and around the local molecular clouds. Despite all of this, they still favor the formation of bubbles through supernovae. If the galaxy is composed of a network of filaments that carry slow-moving ions, these form magnetic fields that hold the structure together. Hannes Alfvén pointed out that these structures are capable of transferring energy over vast distances and dissipating the energy across the double layer with a voltage drop. It is important to understand that the current required to accomplish this may very well consist of low-energy particles. The plasma and material in these areas is not simply mixed together through random collisions. Plasmas have a tendency to produce large variations in the chemical composition. One mechanism is due to the different laws of motion of the non-ionized and ionized components of a magnetized plasma. The condensation of non-volatile substances to grains constitutes another separation mechanism. Any charged grains of dust or ions will feel an attraction towards the filament. As they move towards the filament, if they gain enough speed, they can cause non-ionized material to become ionized. This is particularly so in areas where a pinch occurs. This can cause large areas of low density to be created. At the same time, Markland convection will sort material into radial shells. Together, these could explain the network of bubbles we see throughout our local neighborhood.